So in this video, we're going to talk about right triangle trigonometry. So a right triangle is a triangle in which one of the angles is 90 degrees. Okay, so got a right triangle going on. You see that little square there? That designates a 90-degree angle. Okay, and so maybe you have some other angle theta, right? So if you have sides A, B, and C in a right triangle, we call this side a leg. This B side is another leg. And the C side is the hypotenuse. Okay? The hypotenuse is opposite the right angle. Okay, so this side C is a capital C for the angle. All right, the side opposite the angle. Okay, so this is a lowercase a, so that's a capital A angle. And then you could call this like theta here. That could be like the capital B angle. Okay? So the opposite, the angle opposite the side, those correspond with each other. Okay, the bigger that angle, the bigger that opposite side is. Now, a theorem, a famous theorem, Pythagorean Theorem. The Pythagorean Theorem says if we have a right triangle, then the leg squared plus another leg squared equals the hypotenuse squared. Okay? So, the angle theta that we have right here, this acute angle, this theta is between 0 and pi over 2. Pi over 2, which is equal to 90 degrees. Okay? So measured in radians. And theta is in standard position, right? So let's take a theta in standard position. So there's some theta here, and we've got this point here. All right, so if this is side A, this is side B, and that's side C, that's a right triangle, then we can draw a circle. Okay, the equation of this circle is x squared plus y squared equals c squared. Okay, c is that radius there. Okay, so now we can use trigonometry to define what's going on here. The sine of theta is equal to opposite divided by hypotenuse. So that is equal to opposite divided by hypotenuse, which in this case is b over c. Okay. Cosine theta is equal to adjacent divided by hypotenuse. Adjacent divided by hypotenuse, a divided by c. And then the tangent of theta is equal to opposite over adjacent, which is opposite the angle divided by the adjacent to the angle. So b divided by a here. Now, how do I remember this? It's goofy. You know, we've talked about this in earlier videos, but I say some old hippie caught another hippie tripping on acid. All right, so some old hippie caught another hippie tripping on acid. So sine is opposite over hypotenuse. Cosine is adjacent divided by hypotenuse. And tangent is opposite over adjacent. Okay? All right. Now, cosecant, secant, and cotangent are just reciprocal functions. So once you know sine, cosine, and tangent, you know that secant theta is hypotenuse over opposite. Secant theta is hypotenuse over adjacent. And cotangent theta is adjacent divided by opposite. Okay, it's literally the reciprocal of what we just had. Okay? So what I want to do is I want to take an example. So I want to find the exact value of the 6 trigonometric functions of the angle theta for this picture right here. So I've got a right triangle and I've got an angle theta and I've got, it's a 5 here and a 3 here. Okay, and then this is opposite. So I want to know the 6. So how do I do this? I use Pythagorean Theorem. All right, so a squared plus b squared equals c squared. So what are the legs? What's the hypotenuse? The hypotenuse is opposite the right angle. It's the longest side. That's 5. So 5 squared equals, well, one of my legs is 3. So that's 3 squared plus b squared. So I'm solving for this b here. Okay. So that's 9 plus b squared equals 25. Subtract 9, subtract 9. I get b squared equals 25 minus 9, which is 16. So whenever I take the square root of both sides, I get a plus or minus 4. But when we're talking about this distance here, I'm dealing with a positive 4. So I've got b, I've got b equal to 4 here. All right. Now, when I run through the 6 trigonometric functions, sine theta, cosine theta, tangent theta. Okay, those are the first 3. So sine is some old hippie. So some old hippie, that's opposite over hypotenuse. So that's 4 divided by 5. Okay. Cosine theta is adjacent over hypotenuse, so caught another hippie. So another adjacent divided by hypotenuse, that's 3 divided by 5. And then tangent theta, looking with respect to the angle theta, it's opposite over adjacent, that's 4 divided by 3. 4 divided by 3. Now I want to do the cosecant theta, I want to do the secant theta, and I want to do the cotangent theta. These are the reciprocals of what we just found. So cosecant is hypotenuse over opposite. Secant is hypotenuse over adjacent. And then cotangent is adjacent over opposite. Just like that. All right, so those are the 6 trigonometric function values given this triangle right here. Okay?